Yeah. Yeah, so we're picking it up with 6c from where I left off with the other class. So we have cosine times arcsine negative 4/5. I'll pull things off over here. I'll clear this out. This is where we left off last time. So it does say not to use a calculator on this. What I told the other class is use your calculator to verify your answer, or even find out the answer from your calculator and then make sure your work follows with that. Okay, so 6c, where it's saying this, is effectively saying cosine times the inverse of sine. Okay, sine to the negative first, negative 4/5. Okay, so your final answer, whenever you begin to work all this out, let's see if we took sine is opposite over hypotenuse, correct? All right, so if I had an opposite of negative 4, let's see, over hypotenuse of 5, so let's say we had negative 4, 5, that would give me a 3, 4, 5 right triangle, okay, where I've got negative 4, 5. Okay, and if I wanted a cosine of this, it would be 3 over 5. So I end up getting 3/5 out of that. And whenever I check it in my calculator, I get 0.6, which is 3/5. Okay, does that make sense? Okay. All right. From there, let's see. You guys should have your paper in hand, or at least looking at it on your screen, so I'm not going back and forth between screens on this. Let's see. So number 7 says simplify. We've got log base 3, 3 to the 4th, plus log base 5, 5 to the 3rd, minus log base 2, 2 to the 4th. Now, do you guys remember at all what happens if I have log base 3 to the 3rd? Like, what is that? It's 1, right? So what I'm going to do here is I'm actually going to take all these exponents and move them out front. Okay? Because these logs that have the same base as their number all come out to 1. So essentially what I'm saying is 4 times 1 plus 3 times 1 minus 4 times 1. Okay? Well, those 1s don't really matter, so it's really 4 plus 3 minus 4. The 4s are going to cancel out, and you should be left with, if I'm not wrong here, on 7, 3. Does that make sense?
I think it's 7.
No, I think I said 3. Hope I said 3. Okay, does that help us out there? All right, we know what to do. That's the work. Okay, pretty easy. All right, number 8. Let's see, number 8, solve for x. They give me log base 9, x plus 2, minus log base 9, x minus 3, equals log base 9, 6. Well, it's really nice that all that's log base 9, right? Because what can I do with that subtraction? Turn it into division where I have x plus 2 over x minus 3 equals 6. Okay? If I want to solve from here, I'm going to take the denominator and multiply it, right? So we're going to multiply this side by x minus 3. You could multiply the left-hand side by x minus 3 so that it cancels out. I'm going to get x plus 2 equals, distribute the 6, 6x. Okay, 6x minus 18. Then it's just a matter of isolating x. You could do that a couple different ways. I would probably move the 18 over and subtract this x, because that leaves everything positive. So I got 20 equals 5x, divide by 5, x equals 4. Okay, as I look at number 8, yep, x equals 4. Questions there? None? Okay. All right, number 9, sketch the graph of each function. Okay, let's see. Well, this first one on A comes down to y equals the absolute value of x minus 2 minus 3. So the first thing I'm going to do with an absolute value question is isolate the absolute value. So let's see if I'm not wrong here. Let me double check my notes. Okay, on this I just plugged it into a graphing calculator and got a table of values. So with something like this, that minus 3 here means I'm going 3 to the right, and this minus 2 here means I'm going, hopefully, if I've got this right, 3 to the right, and should be 2. Oh, no, I got it wrong. This means I'm going 3 down. This means I'm going 2 to the right, okay, with an absolute value. And an absolute value graph will always look like a V, okay? So I'm going down 2, or sorry, to the right 2, down 3. So I should get something that looks like this here. So I'm going to draw that graph, and I'm going to have a table of values, X and Y, okay? I want the graph and the table of values, okay? Just as a personal rule, I start at -3, go -2, -1, 0, 1, 2, 3. That usually assures that I'm going to hit everything that I need to, okay? And because that's all we really need to do, okay, I don't think that that's too much work to ask for on that question, okay? Let's see, 9B. 9B gives us 1 over absolute value of x minus 2, absolute value minus 3. Okay? And find my notes here. What I would end up doing here is probably just straight up plugging that in my graphing calculator. You should get something that looks like this. Okay, again, you're going to have a table of values and that graph. Now, you have to be very careful with how you plug this into your graphing calculator. Okay, I'll show you. Okay, so let's go into my y equals. Let's clear all these guys out. Okay, all right, so we're going to do 1 divided by, and the really important here is to put everything that's in the denominator into a set of parentheses. Okay, so that I'm dividing by all of it. The next thing I'm going to do is math. I'm going to go down to, where is it at? Number. Is it yeah, first thing on number, absolute value. And then we're going to do my x minus 2. Close that parentheses, and that effectively ends that absolute value. Minus 3. Close the second set of parentheses up and graph it. Okay, I'm going to zoom so you can see the whole thing. Go to hit zoom standard. Okay, in older calculators, you actually see the asymptote, which is this vertical line, but we actually won't see that on our graph. Okay, but if I do this, I'll tell you what, if you end up doing this wrong, I'm going to tell you what it's typically going to look like. It's going to look like that when you do it wrong. At least a lot of times. They'll end up kind of mushing that together. So we see the gap between the exponential increase and decrease. Okay, we should see that. Okay, so that's 9. All of 9, A and B. Question number 10. Find the equation of a line that is equidistant from points -3, 3 and 5, -1. Write the equation in slope-intercept form. This is where we have these two distance formulas. So I'm starting off with x minus -3 squared plus y minus 3 squared equals x, let's see, x minus 5 squared plus y minus -1 squared. Now, the square roots really don't matter. They kind of cancel each other out. So as I move down, what I'm going to see So I'm going to be writing out the FOILed version of this. This is essentially x plus 3 squared. So what I'm getting is I simplify this. You can do it in smaller steps if you want to. I'm going to do it quickly. Okay. X plus 3 squared is going to be x squared plus, let's see, 6x plus 9, right? And then over here I got y squared. Don't forget that we're switching variables here. So y squared minus 6y plus 9. Okay. All right, coming over to this side. Let's see, that wasn't a -5, so we're good there. So we got x squared minus 10x plus 25 plus y squared. And this is coming out as a positive because I've got two negatives. So I have plus 2y plus 1. All right, from here, we're going to cancel out what can cancel out. My x squareds will cancel. My y squareds will cancel. Okay, everything else is a matter of getting this into a y equals mx plus b form. So I want to move the y's to the left. I want to move the x's and the constants to the right. So I can subtract 9. I can subtract 9. I can subtract 6x from the left-hand side. Okay, so as I come over here, let's see, I am ultimately subtracting 18 from this side, and I am subtracting 6x from 10x. Over on this side, what I want to do is I want to subtract this 2y from this 6y, so I'm getting all my y's over there. Okay, so let's work with what's on the left-hand side. I've got negative 6y minus 2y, which is going to give me negative 8y equals, all right, now let's look at what we've got over here in terms of x's. Looks like negative 16x. And my constants are 25 plus 1, which is 26. 26 minus 18. 26 minus 18. I believe so. I believe it comes out as 8. Okay. It's going to be on the recording. Hello? Uh-huh.
Do you have Window with you right now?
I do. Sure. Yeah. All right. Okay.
Thank you.
Uh-huh. All right. You need to meet, Quinn, you need to meet Clayton and Brett down in the shop, he says. All right, so from here, we're going to divide everything by negative 8. Okay, so I get y equals negative 16 divided by negative 8 is positive 2. And 8 divided by negative 8 is negative 1. So on, what was this, 10? Y equals 2x minus 1. Yes?
Just find the slope and then the midpoint of the 2 points, and then do the perpendicular line to that. Because I did that, I still got 2x minus 1.
If it will work every time. I don't have enough time to like break that down and see if it'll work every time. Well, it works, I mean, you're thinking along the lines of a perpendicular bisector. So, yes, it's going to be a... Okay, so if you're saying to find the slope, or sorry, you have to find a distance between negative 3, 3, and 5, negative 1. So you're finding the midpoint of those 2 points. So you're finding the midpoint, and you're finding the slope and doing a perpendicular slope. I mean, I can't see why that wouldn't work. I guess ultimately a line that's equidistant to 2 points is technically a perpendicular bisector of the line that connects those points. So I can see where that would work. If it works. Now, here's the thing. If you try that and you're wrong on the test, it's wrong. Okay, so just be careful with it. Miles, you had... Yeah, I'll accept it if it's right. If it's wrong, no. All right, number 11 wants you to find the domain. Find the domain of f. All right, so when we're talking about, well, let's go ahead and put it on the board. We've got 2 minus x over x cubed plus 3x squared minus 4x. the first thing that we always start off with when we're talking about domain is we're going to start off with the numerator, okay? Because we're looking for real values on this. At least that's what I'm looking at. So we're saying this, that 2 minus x has to be greater than or equal to 0. It can be 0. We can get a negative inside the square root. We just can't get we can get a 0. We just can't get a negative because then I'm moving into imaginary numbers. So from here, you can subtract 2, right? I'm getting negative x is greater than or equal to negative 2. I can divide by negative 1. Okay, that means that x, I got to flip the sign as I divide by the negative, so x is less than or equal to 2. Okay, so that's where I want to start with. And then, let's see, that seems to be the bigger part. Then we've got this x cubed. X cubed plus 3x squared minus 4x. So notice what you can factor out of that. What can I factor out of this? I can factor out an x. So if I take an x out of this, what I'm left with is I'm left with x squared plus 3x minus 4. Okay, so one thing we know is that I've got that x sitting on the outside, which means x cannot be equal to 0. All right, so as we're looking at x is less than or equal to 2, we know we're not going to be able to use 0 here, and because 0 is less than 2. All right, so from here we've got x. We're plus minus, which means we need to be plus minus in here. Things that multiply to be 4 add up to 3. In this case are going to be, 4 and 1, right? Okay, so we know this is that as we set these separate factors equal to 0, is that the end? No, I don't think so. That's the end of the class? Let me double check. You guys should get out of here. 5th. Yep. See you guys later. All right, I'm going to finish this question because I don't have anybody coming in. So x would be equal to 0 here. X would be equal to negative 4. X would be equal to positive 1. And all of those are less than 2. So what we're saying here is that x is a set of all real values such that x is less than or equal to 2, but x is not equal to, start with the least, negative 4, 0, or 1. Okay, because all of those values, because all of those are the zeros to my denominator. If I have 0 in the denominator, again, it's an irrational, it's an imaginary or unreal number. So that's the end to, what was that, question number 11? All right. What I'll probably do from here is continue to work these out during my plan period so I can get as much of this done and get it all out to you under only 2 files. All right. Test tomorrow. See ya. All right. Question number 12 for nobody in here. All right. It is possible to plug this into your calculator, but I've noticed that there's a lot of discrepancies between how they come out. First thing you want to know is this bottom number means minimum, this top number means maximum. So we're going to go through here because this term means summation. So the first thing I'm going to do, I like to do these out the long way, is I'm going to start with 4 times 1 minus 2 times 1 squared, okay, and solve that. Plus, because we're doing summation, then we move up 1. So 4 times 2 minus 2 times 2 squared, break. Plus, and because we're only going up to 3, okay, we're going to do 4 times 3 minus 2 times 3 squared, done. So I'm going to go through here, we'll break down these separate segments. 4 times 1 is 4, minus 2 times 1 squared, well 1 squared is 1, so I'm just getting minus 2. And so I'm getting 2 as my answer there. So I come over here, I've got 4 times 2, which is 8. I've got 2 squared, which is 4. So I've got a negative 2 times 4, which is negative 8. So I'm getting 0 out of that. Over here I've got 4 times 3 is 12. 3 squared is 9. So negative 2 times 9 is negative 18. So I'm getting what appears to be negative 6. So 2 plus 0 plus negative 6 should get me an answer of negative 4. Okay, I'll double check that. Negative 4 is our answer. All right, we'll move on to number 13. If I can get this to erase. Okay, 13. Determine if f to the x equals 1 plus 2x plus 1 and g of x equals 1 minus x over 2x are inverse functions by computing their compositions. So what we want to do here is first we're going to do f of g. So we're going to take f and we're going to plug g in for x and see if we get negative 1, if we get x out of it. Okay? And then when we do that, if we do g of f, where we take g and we plug in f of x into the x values, and when it simplifies, if it gets down to x, if I get x for both terms, where everything else cancels out except x, then I know that they're inverses. So these are pretty tricky. So we're going to start off with 1 over 2 times. Well, so what's going to go in here is 2 times all of g of x. So 1 minus x over 2x plus 1. Okay, so we're going to try to simplify that as much as possible using order of operations. So this next step is I bring it down. I'll probably bring it down and move it back up to the right as we do this. So I'm going to distribute the 2 to the numerator. So I'm going to get 2 minus 2x over 2x plus 1. Okay? All right, and I'm going to move that up here. So I've got 1 over, and in this fraction, I can factor out the 2's so that I get 1 minus x over x plus 1. Okay? Now what I have is I have two sets of fractions I'm trying to add together. So I can multiply this 1 over 1 times x over x to get that common numerator, common denominator. So I've got 1 over 1 minus x plus x all over x. So if you'll notice in here, my x's are going to end up canceling out. So as I bring that up, I got 1 divided by 1 over x. Well, this 1 on top here is really 1 over 1. So I've got a fraction 1 over 1 divided by 1 over x. So I'm going to multiply by the reciprocal. That's going to leave me with x over 1, which is just simply x. So that's a good sign. That means whenever I plug g of x into f of x, it reduced down until I got x. Which, if it had come out to anything else, I would have known that these are not inverses of each other. So you might want to take a look at that, even backtrack and make sure that you understand all the steps, because I'm going to erase all this in 3, 2, 1. Okay? All right. Harder yet is to put f of x into g of x, because g of x has 2 x's. So as we start this, we have 1 minus parentheses 1 over 2x plus 1 over 2 times 1 over 2x plus 1. Okay, so you can kind of see now why it's a little harder to go this route. Okay. Let's see, I'm going to go to the right and then scroll down as we look at this. Okay. Let's see. I'm going to start off, just because it's a little easier, start off with the denominator. So I'm going to put that, I'm going to multiply my numerators and my denominator. So I have 2 over 2x plus 1. Now I've got to look at, 1 minus 1 over 2x plus 1. So essentially, because it's just two fractions just simply being subtracted, that it is possible to simply do away with that set of parentheses and look at this as 1 over 1 minus 1 over 2x plus 1. So I've got two fractions where I'm subtracting, which means I've got to get a common denominator. In order to do that, in this case, I have to multiply by 2x plus 1 over 2x plus 1. Okay, so let's look at the results of that. We're going to get 2x plus 1 minus 1 all over 2x plus 1. Okay. Then we'll see in that numerator of numerators that the 1's cancel out, leaving me with 2x over 2x plus 1 over 2 over 2x plus 1, if I'm not wrong. Okay? Which means now it comes time to multiply by the reciprocal. So multiply all of that, multiply all of this. So I'm going to kind of break line here and see what that looks like. All right, so we've got 2x times 2x plus 1. So if I look at that, we're going to take and we're going to distribute our 2x to our 2x, which would be 4x squared, and 2x times 1, which is plus 2x. Okay. And set that over 4x plus 2. Now what looks to me is that I can factor out a 2 from all of this, which is going to leave me with 2x squared, okay, plus x all over 2x. Let's see, 4x squared plus 2x over 4x plus 2. Factor out, we got 2x squared plus x all over, should be 2x plus 1. Okay? Sorry about that. So if you look at our top row, I kind of jumped here. I looked at the 2x squared plus x. Well, we can factor an x out of that. We can't get rid of it, but what we wind up with is x times 2x plus 1 over 2x plus 1. And our 2x plus 1's cancel out, and they leave us with just x. And because I'm left with just x on both of them, they are inverses of each other. Okay, so a lot of really complicated work. I would assume that not very many people are going to do that question. But if you did, that's how. Okay, 14. So the answer on 13 was yes. At the end of it, the answer was yes. Okay, 14, find the standard form of the equation of a circle whose center is at -3, 2, and has a radius of 5. So our standard form of the equation is x minus h squared plus y minus k squared equals r squared. So we're going to plug these things in. So I get x minus -3 squared plus y minus 2 squared equals 5 squared. All right, we're going to simplify this a little bit. So we're going to write x plus 3 squared plus y minus 2 squared equals 25. That is our answer there on 14. X plus 3 squared plus y minus 2 squared equals 25. You could have also written that as 5 squared. I'd take it either way. Okay. All right. 15. Let's see, it gives you a picture. Looks like something like that. P N O L M. And as most people don't tend to do the proofs, I'm going to be pretty quick about this. And you're looking at the page, they tell you that Ln is congruent to Pn. So Ln is congruent to Pn. Okay. They tell you that Mn is congruent to On. Okay. And we want to write a two-column proof to show that L, this angle, is congruent to angle P. Okay? So you can start off with, whenever you're doing this, you should start off with your givens. So they list two givens for you. I'm not going to rewrite those down. Okay? The next thing I want you to see, you should see already, is that angle, let's call it OPN, is congruent to angle, if it's OPN, then it's going to be M. Let's see, and that wasn't P to begin with, was it? Let me start over here. Angle ONP is congruent to angle M in L. Okay, because vertical angles are congruent. Okay, that's what you see there in the green. Okay, so we've got vertical angles. And so what that's giving me here is side, angle, side, side, angle, side. So I can say, you know, my triangle ONP is congruent to triangle M in L through side, angle, side, congruency postulate. And then our final one is angle L is congruent to angle, what was it, P through CP, CTC, because they're corresponding parts of congruent triangles that are congruent. Okay, that's what you're looking for there. That was 15. Okay. 16. Sine 13 pi over 6 plus tangent 8 pi over 3. First thing, convert your radians to degrees. So you substitute in 180 for pi. 13 times 180 divided by 6 is 390 degrees. So we want sine of 390 degrees plus tangent 8 times 180 divided by 3 comes out to 480 degrees. Okay, well, on 390 degrees, it's positive, so we're going all the way around, which would get you to 360. All right, which means we have a remaining 30 degrees, so 30, 60, 90. We're at 1, radical 3, and 2 if you know your special right triangle ratios. Tangent 480, so I'm going to take 480 and subtract 360, see where I actually wind up at. I actually wind up at 120 degrees, so that's leaving me here. 60 left, 30, okay, there, so I'm at 1, actually negative 1, radical 3, and 2, because we want sine of this first one. That's opposite over hypotenuse for my reference angle, so 1/2 plus tangent on our other one, so opposite over adjacent, which is radical 3 over negative 1. Okay, well, I'm trying to add two fractions together here, which doesn't work the way that this is situated. Okay, so let's see if we can do something with this. We could make this a little bit easier by moving that negative up to here. And we have over 1. So we can multiply all of this by 2 over 2. So we've got 1/2. Okay. minus 2 radical 3 over 2. Okay, and that's our answer. That's literally it. This is it right here. It won't, you could write that as 1 minus 2 radical 3 all over 2 if you wanted, right there. Let's do this one so you understand. That's what we're looking at. Okay? All right. So we've got that. Let's see, that was 16. All right. 17. 17, the 6th hour ceramics class of 22 students. Okay, this looks like a rate times workers times time. Looks like I've got 22 students. We've got 9 hours. We are making B vases. All right, so the first thing I want to solve for is R. 9 times 22, okay, is 198. So R equals B divided by 198. So we're going to keep B over 198 as they change up some things on me. If 2 students were absent, which means we're down to 20 students, we're going to solve for time and how long would it take them to make 30 vases. All right, so what we have now is 20B over 198 times T equals 30. We want to take 30 and multiply it by the reciprocal of 20B over 198. So that's really 30 over 1 times 198 over 20B. So let's go ahead and simplify 30 times 198. Okay, that's 5940. Okay, 5940 divided by 20B. Well, we could see if that'll simplify. Let's take 5940 divided by 20. It actually comes out to a full 297 on the dot over B, and because it's time in hours, our answer is right there, 297 over B hours. Try this again. Try it another time. There we go. And there. All right, 18. 18, find the coordinates of the point halfway between 412 and 22. Okay. Coordinates halfway between are going to be what is considered the midpoint. So 4 plus 2 divided by 2, 12 plus 2 divided by 2, 4 plus 2 is 6, 6 divided by 2 is 3, 12 plus 2 is 14, divided by 2 is 7. Let's check and see if 37 is it. Maybe one of the, if not the easiest question on the test. Okay. All right, 19. Evaluate secant 240 degrees plus cotangent 495. Okay, all right, at 240 degrees, that's taking us 60 degrees south of 180. So I wind up with this, where I have -1, negative radical 3, and of course a positive 2. At 495, I'm going to subtract 360 from that. Find out what that really comes out to. It really comes out to 135. So at 135, we are 45 degrees shy of 180. So I'm at 1, -1, radical 2. Now I'm looking at these terms themselves. Okay, we want the secant. Secant is reciprocal to cosine. So what we want is hypotenuse over adjacent. So 2 over -1, or really -2. But over here, cotangent is reciprocal to tangent, so it's adjacent over opposite. So it's -1 over 1. So really what I have is I have -2 minus 1 which is giving me negative 3. Double check our work on that. Negative 3 is our answer. Okay. Hopefully all that makes sense to you. Number 20, write the equation of the sinusoid. So I'm going to flip back over to the picture so you can see what I'm talking about on this. Let's see. All right, 20. Okay, so we're looking at this. Notice that it crosses through the origin. All right, so we're going to start off with y equals. Okay. Let's see. They're keeping this pretty simple. The next thing on my list is amplitude from 0. It's going in a positive direction up to 5. Because it's crossing the origin, I know that it's a sine function. And because they're using x, I know it's x. So y equals 5 sine x. That is all there is to that. I hope that's enough information for you guys to be able to get a good study in on your test for tomorrow. All right, and stop there.